Before diving into this story, there's something worth clearing up directly, because the exact claim in some viral headlines about this topic doesn't hold up. You may have seen versions of this story online claiming James Webb discovered 900 billion stars that mysteriously vanished from the universe, quoting an astrophysicist supposedly named Dr. Elaine Matthews from something called the Space Science Institute. That specific claim, traced back through its original sources, doesn't appear in any NASA release, any peer-reviewed journal, or any university press office anywhere. It shows up only on low-quality aggregator blogs that have been recycling the identical wording since early 2025, with no verifiable scientist behind it. It's the kind of story that sounds plausible enough to spread, but simply isn't real science. Here's what actually is real, and it's genuinely stranger and more interesting than the invented version. James Webb has spent years studying an actual population of stars that don't belong to any galaxy at all, drifting alone in the space between them, essentially homeless, torn loose from the galaxies that once held them. Astronomers call them orphan stars, and in the massive galaxy clusters where they have been found, there are, by real peer-reviewed estimates, trillions of them, making up a genuinely enormous fraction of all the stars in some of the largest structures in the observable universe. This is the real story of what James Webb actually discovered about these homeless stars, the ghostly light they produce, and what that light is revealing about one of the most mysterious substances in the entire universe. I'm your host, and this is your channel. If you want the real science behind the biggest discoveries in space, subscribe now, because we're just getting started. To understand what orphan stars actually are, you first need to understand the environment that creates them, because these stars don't form this way. They end up this way through slow, violent gravitational processes playing out over billions of years inside some of the largest structures the universe has ever built. Galaxy clusters are exactly what the name suggests. Enormous gravitationally bound collections of hundreds or even thousands of individual galaxies, all orbiting a shared center of mass, packed together far more densely than galaxies are typically spread out across the universe as a whole. Inside these crowded environments, galaxies don't just drift past each other peacefully. They collide, merge, and repeatedly tug at each other's outer edges through raw gravitational force, and every one of those interactions has the potential to rip stars away from the galaxy that originally hosted them. When a star gets stripped away from its home galaxy through one of these violent tidal interactions, it doesn't simply vanish. It keeps existing, still burning, still producing light, but now drifting freely through the space between galaxies, bound only to the overall gravity of the entire cluster, rather than to any single galaxy within it. Astronomers call this population of drifting homeless stars orphan stars, and the combined extremely faint light they collectively produce across an entire galaxy cluster is called intracluster light, sometimes described by researchers using more evocative language as ghost light or ghostly light, because it's so dim and so diffusely spread out that it looks almost like a pale haze rather than anything resembling a distinct, recognizable source. Before James Webb existed, studying the specific population of stars was genuinely difficult, and understanding why helps explain exactly what made Webb's contribution to this field so significant. Intracluster light is extraordinarily faint, so faint that in some of the earlier studies conducted using the Hubble Space Telescope, researchers described the total brightness of this ghostly light as representing just 1% of the darkest sky visible from Earth, an almost imperceptibly dim signal buried in the much brighter light coming from the cluster's individual galaxies. Detecting and properly separating that faint signal required extraordinarily deep, long-exposure observations, and even then, earlier instruments could only trace this light out to a limited distance from a cluster's center before the signal became too weak to reliably distinguish from background noise. James Webb changed that almost immediately after it became operational. In December 2022, astronomers Mireia Montes and Ignacio Trujillo, researchers at the Instituto de Astrofísica de Canarias in Spain, published the first comprehensive study of intracluster light using Webb's own data, examining a massive galaxy cluster called SMACS J0723.37327. The same cluster featured in Webb's now famous first deep field image, released to the public in July 2022. Using Webb's near-infrared camera, the team was able to trace this faint, ghostly light out to a radial distance of roughly 400 kiloparsecs from the cluster's center, twice as far as previous Hubble-based studies of similar clusters had ever managed to reliably detect. The published research described what this deeper, more sensitive view actually revealed about how the cluster itself had formed. The inner regions of the cluster, closer to its dense core, showed clear evidence of having been built through a major galactic merger, two large structures colliding and combining directly, while the outer regions, farther from the center, appear to, have been built through a more gradual, ongoing process, smaller galaxies being slowly stripped of their stars over time as they continued orbiting within the cluster's gravity. Trujillo, discussing the broader significance of being able to study this population of stars in such detail for the first time, connected the discovery to something well beyond simple: stellar bookkeeping. Webb, he explained, will let researchers characterize the distribution of dark matter within these enormous structures with unprecedented precision, offering real insight into its basic underlying nature. That connection between orphan stars and dark matter, one of the most persistently mysterious substances in all of physics, is worth explaining carefully because it's the real reason this research matters so much to the broader field of cosmology, well beyond simple curiosity about where some stars happen to be floating. Dark matter makes up roughly 85% of all the matter in the universe, yet it doesn't interact with light at all, meaning it can never be directly photographed or observed the way ordinary matter can. Scientists can only infer its presence and its distribution indirectly, by studying how its gravitational influence affects things that are visible, the rotation speeds of galaxies, the bending of light around massive clusters, and, crucially, the movement and distribution of exactly the kind of orphan stars James Webb has been studying. Because these stars aren't gravitationally bound to any single galaxy anymore, having been stripped away and set loose within the cluster as a whole, their motion is governed almost entirely by the overall gravitational field of the entire cluster, a field dominated overwhelmingly by dark matter rather than by the visible galaxies themselves. That makes the distribution and behavior of orphan stars an unusually direct, unusually clean tracer of exactly where dark matter actually sits within a cluster's overall structure, a genuinely valuable diagnostic tool that simply wasn't available with this level of precision before Webb's data made it possible. A separate but closely related study published in 2024 using data from the European Space Agency's Euclid mission added further genuinely surprising detail to this picture. Led by Professor Nina Hatch, the research team examined orphan stars within a different galaxy cluster and found something the astronomers themselves described as unexpected. Based on prior assumptions, researchers had generally expected these E-stripped homeless stars to end up orbiting around the single largest, most massive galaxy typically found near a cluster's center. Instead, Hatch's team found that the orphan stars in their study were actually orbiting around a point positioned between the two most luminous galaxies in the cluster, rather than centered on either one individually. Hatch explained the broader implication of the finding directly. Researchers were genuinely surprised by how far into the outer regions of the cluster they were able to trace this light, and by how clearly the subtle color variations within it could be distinguished. By carefully studying the specific colors, brightness levels, and overall configuration of these orphan stars, the team determined that they had originally come from small galaxies. Stars torn loose specifically from the outskirts of larger galaxies and from the complete gravitational disruption of smaller dwarf galaxies caught up in the cluster's crowded environment. The orphan stars themselves carry a distinctive bluish hue and tend to appear in loose, clustered arrangements, physical characteristics that gave researchers real clues about their specific origin story, even without being able to trace any individual star back to one specific parent galaxy directly. Research into this population of stars has continued accelerating since these initial studies, with astronomers using Webb to push the boundaries of how far back in cosmic time this phenomenon can actually be traced. A study published in 2026 examined intracluster light within a galaxy cluster, designated XLSSC 122, sitting at a cosmic distance corresponding to roughly 10 billion years in the past, making it, at the time of publication, the most distant known galaxy cluster with a sufficiently evolved stellar population to study this specific phenomenon in real detail. Using Webb's deep infrared imaging, combined with archival Hubble data, and careful modeling to separate different sources of light within the cluster, researchers measured that intracluster light already accounted for roughly 17% of the total stellar light within this ancient cluster, direct evidence that the process of stars being stripped away from their home galaxies and set loose within a broader cluster structure was already well underway less than 4 billion years after the Big Bang itself. That finding matters because it demonstrates this isn't some late, recent phenomenon in the universe's history. It's been happening for most of cosmic time, a slow, continuous process of galactic disruption and stellar displacement that has been quietly building up enormous, essentially invisible populations of homeless stars for billions of years. It's worth trying to actually convey the real scale of this phenomenon, because even without resorting to any invented or exaggerated numbers, the honest figures here are genuinely staggering. In some of the largest, most massive galaxy clusters studied by astronomers, intracluster light and its associated orphan star population can account for a substantial fraction. In some cases, reportedly as much as half of the cluster's entire total stellar light output, depending on the specific cluster's age, mass, and dynamical history. Multiply that fraction across the scale of a massive galaxy cluster, some of which contain T-thousands of individual galaxies, each with hundreds of billions of stars of their own, and the total number of individual orphan stars scattered throughout these structures genuinely does reach into the trillions, a real peer-reviewed, scientifically grounded figure, even though it describes something categorically different from the fabricated 900 billion stars vanishing claim that circulates in less credible corners of the internet. The reason this matters goes beyond simply cataloging an enormous number of stars for its own sake, because intracluster light directly traces the gravitational history and internal structure of a galaxy cluster, and because it serves as an unusually clean tracer of dark matter distribution, this research represents a genuinely important, active frontier in modern cosmology, one that Webb has meaningfully advanced simply by being sensitive enough and having sharp enough resolution to detect signals that earlier instruments could only partially glimpse. NASA's own Roman Space Telescope, currently scheduled to launch in the coming years, is specifically being designed with wide-field, low-surface brightness observations in mind, precisely because researchers recognize how valuable studying intracluster light across large numbers of galaxy clusters could become for understanding both galaxy formation and the underlying distribution of dark matter throughout the universe at a genuinely large statistical scale. So here is where this actually leaves things, honestly, grounded entirely in real, peer-reviewed research rather than a fabricated viral claim. James Webb did not discover 900 billion stars disappearing from the universe, and there is no verifiable scientist named Dr. Elaine Matthews behind that specific story. What Webb has genuinely discovered and continues to study in ongoing active research is a real population of trillions of orphan stars, stripped from their home galaxies through billions of years of gravitational violence within massive galaxy clusters, drifting freely as a faint, ghostly haze of light that researchers can now trace further and more precisely than ever before. That light is helping scientists map the invisible distribution of dark matter throughout some of the largest structures in the universe, tracing the deep, violent history of how these clusters actually assembled themselves over cosmic time, and revealing that this process of stellar displacement has been quietly unfolding for most of the universe's entire history. That is not manufactured drama. That is the honest, verifiable, genuinely fascinating science that real astronomers have published with real names, real institutions, and real data, standing entirely on its own without needing any invented embellishment at all. If this kind of story is what you come here for, one grounded in exactly what real scientists have actually measured and published, rather than fabricated viral claims, hit subscribe and turn on notifications, because there's clearly more genuine mystery in the real universe than any invented headline could ever offer. Drop a comment telling me whether you'd heard the fabricated version of this story before, and share this with someone who deserves the real science instead of a headline built from nothing.